Hello friends, in this video we will learn what is switching modulator and how does it generate amplitude modulated signal. So let's begin. So in switching modulator circuit there will be a carrier signal in series with message signal. Okay, both will be in series combination, and the series combination of the carrier and message will be passed through a diode's D. So the operation of diode will totally depend on CT. Why we'll see here. This node voltage is V1T and this node voltage is V2T. So V1T is equal to MT plus AC cos 2 pi CT. It is clear. Now the amplitude of the carrier is very greater than the message signal amplitude. So the diode will be on when the V1 will be positive, and diode will be off when V1 will be negative. So when V1 will be positive, when amplitude of message plus carrier will be positive. Now amplitude of message is very less than carrier, so we can say V1 will be positive when carrier will be positive, CT will be positive. So V2 will be equal to V1, means diode will be on when CT will be positive, and when CT is negative the diode will be off and V2 voltage will be 0. Okay, so now we can write this expression: V2 is equal to MT plus AC cos 2 pi CT when CT is greater than 0, and if it is negative it will be V2 will be 0. Now we can replace this condition with a function GPT. So V2 equal to V1 into GPT. What is GP? GP is a rectangular pulse which width will be the carrier pulse width for positives half. And now it will be clear. So GP will be this rectangular pulse strain. Why we have written this? Because if you know what is the CT will be like this. Okay, so for all value of CT the rectangular pulse strain is 0, and for positive half of CT the rectangular pulse is unity. So when CT is positive GP is 1, when CT is negative GP is 0. We want that only, na? Okay, so it is clear now. When CT is positive GP is 1, when CT is negative GP is 0. Okay, now we want the final expression V2. Okay, so now we can represent GP in terms of mathematical Fourier series coefficient terms. So if you derive Fourier series coefficient, if you know, you can derive it. You will find like this: 1 by 2 plus 2 by pi cos 2 pi CT minus, here sine term will be 0 because this is a even function. For even function Bn will be 0 and A0 and An will be non-zero. So you will get like this. Now V2 equal to MT plus AC cos 2 pi CT into GPT. We know GPT is like this. Okay, now you have to pass this whole expression with through band pass filter with center frequency FC. What you will get? DC term MT into 1 by 2 is a DC term, will be blocked. MT into 2 pi by pi cos 2 pi CT will be passed because its bandwidth means its frequency will be FC plus FM to FC minus FM, so it will be passed. This is that component. And AC cos 2 pi CT into 1 by 2 will be passed. This is that component. And AC cos 2 pi CT into this cos 2 pi, you will get DC plus 2 FC term will be blocked. So you will get this final expression: V2 equal to AC by 2 cos 2 pi CT plus 2 by pi MT cos 2 pi CT, which is very similar to actually it is a EM signal, but similar to standard equation of amplitude modulated signal, which was AC cos 2 pi CT plus AC MT cos 2 pi CT into Km. Okay, I hope you learn what is switching modulator and how you can derive the how you can generate the amplitude modulated signal through it. Okay, thank you.